Titrations are used to determine the concentration of an unknown solution, the stoichiometry of a reaction, the number of electrons transferred in a reaction, and solubility products. Before you begin the titration, you must check the glassware for cracks or chips. You must then prime the burette by rinsing it first with water and then 3 times with a sodium hydroxide solution.
The two solutions involved in a titration are called the analyte and the standard solution. The analyte often has the unknown concentration. In this experiment, the analyte is the sodium hydroxide solution and the standard is potassium hydrogen thiolate, otherwise known as KHP. The sodium hydroxide is added dropwise to the Erlenmeyer flask from the burette until the endpoint is observed.
The volume of the sodium hydroxide dispensed must be determined by difference. Read and record the initial and final volumes to 2 decimal places.
Because sodium hydroxide is a strong base and KHP is a weak acid, when the reaction reaches the endpoint, the indicator phenolphthalein will become a faint pink. Be cautious when dispensing the sodium hydroxide because 1 drop can send the solution past its endpoint. If this occurs, the volume used to determine the unknown concentration will be incorrect.
Before performing the titration, you must know the concentration of the standard solution, the initial volume of the analyte, and the mass of the standard solution that will react with the analyte. To determine the unknown variable, in this case the concentration of the analyte, you must use the moles of sodium hydroxide, which was determined by the mass of KHP, and then divide that by the volume of sodium hydroxide.
The data for each trial should be recorded in your lab notebook.